Here we go. I'm gonna get at least one more knocked out here before I go home. So we're gonna do it Unit 6 on our trigonometry final exam review. This was all about proofs, right? Now the biggest identity that we needed to focus on was sine squared of theta, ABC, whatever angle you want to call it, plus cosine squared. That was equal to 1. All right, that was a big one. Another one we had was the cosecant squared. Let's do it. Cosecant squared minus the cotangent squared. That also equaled 1. And then the last one we had here was the secant. Secant squared minus the tangent squared. Believe it or not, that one's also equal to 1. So with that in mind, we could say sine squared is equal to 1 minus cosine squared, or we could say cosine squared equals 1 minus sine squared, and so on and so forth. Similarly with cosecant, cosecant squared is 1 minus cotangent, and then secant squared is equal to 1 plus tangent. Those are going to be some that you need to, I don't want to say memorize, but at least kind of be aware of when we're going through, when we prove these things. And then I guess another thing is tangent. The tangent of theta is equal to the sine of theta over the cosine of theta. The cotangent is the reciprocal of that. That is equal to cosine of theta over the sine of theta. And then two more, since I'm on this page, we're going to say that, let's see here, the secant of theta is equal to 1 over the cosine of theta, and the cosecant of theta is equal to 1 over the sine of theta. All right, so the purple ones are what we call the reciprocal identities. I guess there's one more. Tangent is equal to 1 over cotangent. All right, these are your reciprocal identities. The green ones are your ratio identities. And then the three that we have over here, the black, the red, the blue, those are your Pythagorean identities. All right, so those are going to be things that you need to be aware of in order to do this section here. So what I would really recommend doing first is anytime you see a cosecant, a secant, a cotangent, change those into sines and cosines. That is going to really help us out here. So this first one, remember, you're only allowed to work on one side. So that sine squared you see on the right side, I'm not going to even touch that, right? So this first one, I got 1 minus the sine of theta times the cosine of theta. All right, I'm going to take that cotangent and I'm going to change that into the cosine of theta over the sine of theta. All right, and now just looking at that, all three of these things, that's all being multiplied together. So what I can do is I can take this sign that's in the denominator, I can cancel it off. That sign that's kind of on the side there. So what's left over is 1 minus the cosine of theta times the cosine of theta. But cosine of theta times cosine of theta is really the cosine squared of theta. And that is that Pythagorean identity we talked about. This is equal to the sine squared of theta, all right, which matches the right side of our equation, right? So we went through, we didn't skip any steps. All right, this step right here, you could probably skip that one. But that is just how we prove these things. We don't manipulate it by adding stuff to one side or the other. We pick a side and then we prove that that left side is in fact equal to the right side. All right. It does not matter which side you start on. Generally, you look at the one that's more complicated and you try to condense it down. It's easier to condense stuff down than it is to kind of expand stuff out. All right, so on this next one here, I see a cosine. I see a cosine of theta plus that tangent. I'm going to change into the sine of theta over the cosine of theta, and this is being multiplied by the sine of theta. All right, we want to show that this mess is equal to a secant. All right, so here's where we're at. I see a cosine of theta, all right, plus we have a sine squared of theta, right? Sine times sine gives us that sine squared over a cosine. Okay. Now, looking at this, I see a fraction, and then I see a not fraction, right? So you can always make them both fractions by putting it over 1. And this is going to be kind of one of those strategies that we need to use here. We need to get some common denominators, all right? So what I'm going to do is I'm going to take that one that's on the leftmost, and I'm going to multiply it by the cosine over cosine, right? So this whole thing right here turns into cosine squared of theta over cosine. Right? Those are equivalent. And then we have this plus sine squared of theta all over cosine of theta. Right? Now, if you look at these two fractions, you're probably saying, hey, those are common denominators. And you're right. So we can say the cosine squared of, oh, dang it. I don't know what I just did. Cosine squared of theta plus the sine squared of theta. That is all over a single cosine of theta, right? Those are common denominators, so you can stick them all together. Right? Now, here is our first Pythagorean identity. This thing is equal to 1, right? So this turns into 1 over the cosine of theta. And of course, 1 over the cosine of theta is equal to the secant of theta, which is exactly what we're trying to show. These two things are equal, right? So there we have it. All right. Now, on to the next one here. 1 minus 2 sine squared. Ooh. Let's see what's going on here. All right. Factoring on this one. Think about this. If you have 1 minus 2x squared plus x to the fourth, that factors into 1 minus x squared times 1 minus x squared. All right. We're going to do the same thing here, but with cosines instead. All right. So I'm sorry, with sines rather. So this is going to factor into 1 minus cosine squared of theta times another 1 minus cosine squared of theta. All right. I keep saying cosine. Why am I? Sorry, guys. These need to be sines. This needs to be a sine. And this one needs to be a sine. I don't know why I keep doing that. Sorry. All right. But from here, we know that this guy equals cosine squared of theta. And this one also equals cosine squared of theta, right? These two things being multiplied together, so those two cosine squares are being multiplied together, and that leaves us with the cosine to the fourth of theta. Okay. And there we have it. That's what we are trying to get to, and that's what we have. All right. Now we're trying to get to a tangent and a sine of theta. All right, this one. Look at that top. I'm just going to rewrite it. 1 minus cosine squared of theta all over cosine of theta. Right. This top here, this 1 minus cosine squared of theta, this equals sine squared of theta. So I'm going to take that whole top and I'm going to turn it into the sine squared of theta all over cosine of theta. Right. Now, this next step, if you're comfortable with these things, you probably don't need this next step, but here's kind of what's going on. I'm going to split this up into sine of theta times the sine of theta, and that is all over the cosine of theta, right? So look at this, sine over cosine. Well, what is the sine over the cosine? That is the tangent. So this turns into the tangent of theta times the sine of theta, which of course is what we were trying to get to, right? So these two things are equal. Tangent of theta times the sine of theta. And that one's done, right? So this section, it can go really quickly, but they can also get pretty complicated. So I'm going to guess these ones on the next page are relatively, a little bit more complicated. So on this one, what can we do here? I'm going to distribute this cosecant in, right? So we're going to have cosecant of theta times the cosine of theta plus the cosecant of theta times the sine of theta. Now, change your cosecants to 1 over sines, right? So we're going to have this first guy right here turns into, you're going to have a cosine. Oh, here. We'll just do it in 2 steps. We're going to have 1 over sine of theta times cosine of theta, plus we have 1 over sine of theta times the sine of theta. So our next line looks like this: cosine of theta over sine of theta, plus we have sine of theta on top over sine of theta on bottom. And if you can notice, this guy right here equals 1, and this guy right here equals a cotangent. So we're really there. So we're going to end up with the cotangent of theta plus 1, which again is what we wanted to get. All right. Now the next one, let's see, secant over sine. So this turns into 1 over cosine of theta all over sine of theta minus sine of theta over the cosine of theta. All right, so that first one looks ugly. You got a fraction inside of a fraction. So if we clean that up, we end up with actually that cosine just moves downstairs. We have the cosine of theta times the sine of theta minus sine of theta over cosine of theta. So this is going to be one of those strategies where we have to get the common denominator. So this one that is on kind of the right side of the two is missing that sine factor. So I'm going to put a sine of theta factor on both of these. Right now, the first one, I'm not going to change at all. Just 1 minus cosine of theta sine of theta. Right. But the next one is sine squared of theta all over cosine sine. So what we're going to have on the top, this is 1 minus sine of theta. So I'm sorry, 1 minus sine squared of theta all over cosine of theta sine of theta. Right. And if you're kind of looking ahead here, this guy right here equals cosine squared of theta. Right. So I'm running out of room here, so I'm going to call this cosine of theta times cosine of theta. Right, that is cosine squared all over cosine of theta times the sine of theta. And what you're going to see is that those two cancel out, and these two equal the cotangent, which is probably what we were trying to get to. Yep. So there we have it. All right. On to the next one here. Use the sum and difference identities. All right. Cosine of theta. Cosine of 2 theta is really just cosine of theta plus another theta. All right. And talked about these in the last one. If you want to think about this as your A and your B values, we know that it's going to think about this, the cosine of A plus B equals, what is that one? Cosine of A plus B is cosine of A times cosine of B. But this one does flip, so minus sine of A times the sine of B. All right, so now just on this problem, the only difference is A and B are theta. They're the same thing. All right, so we know that the cosine of theta plus theta is going to look kind of redundant here, but we're going to have cosine of theta times cosine of theta, right, minus sine of theta times the sine of theta. All right. And then the next one here is, we're going to call this cosine squared of theta minus sine squared of theta. So they're asking us to get cosines. So what I'm going to do is I'm going to change this guy here. This is 1 minus cosine squared of theta. All right, but we have to be careful how we do this. Otherwise, we're going to end up with the wrong thing. We're going to have cosine squared of theta minus, all right, then this whole thing is 1 minus cosine squared. That needs to be in parentheses. All right. So let's see, we're going to have cosine squared of theta minus 1 plus cosine squared of theta. That ends up being 2 cosine squared of theta minus 1, which is what we wanted to end up with. All right. One more, and I can go home. Use the half angle identity to prove the following. Well, this one is kind of, this one's kind of already written for us. So let's look at this. We know 2 sine of theta. I'm gonna do this. I'm using A. 2 sine of A times the cosine of A equals sine of 2A. All right. So we need to use a half angle identity here. Oh, I know what they're asking. All right, this is no good. All right, let's do this. Coach Hall come up with some tricky questions here. Sine of theta over 2, that is square root of, I'm gonna, let's see here, square root of, we have 1 minus the cosine of theta over 2. Right? And this is times another square root of 1 plus the cosine of theta over 2. All right. So kind of remember these identities here. These are the half angle identities that they're asking for. We talked about these in our last unit. These guys on the very right. So sine of theta over 2 is 1 minus that one. So that's where I got those from. So multiplying these two things together, we're going to have 2 times. All of this now is under one big square root. All right, so you have this 1 minus cosine of theta times 1 plus the cosine of theta, all right, over a 4. So, I'm just going to keep going. We could take care of the 4 now. I'll save it for the end. So we have this square root of double distribute at the top. So 1 times 1 is 1. 1 times cosine is positive cosine. So positive cosine of theta. Negative cosine times 1 is minus cosine of theta. And then, of course, the last one is minus cosine squared of theta. And that is still all over 4. Now from here, these are conjugates, 1 minus cosine, 1 plus cosine. So if you notice that, you probably could have skipped this step because you know that those two cancel out. All right. But If you don't remember that, that's okay. We can still get there just using our algebra rules. We have 1 minus the cosine squared of theta over 4. All right. Now, keep in mind, this thing in the middle here is equal to the sine squared of theta. All right. So we have 2 times the square root of sine squared of theta all over 4, which equals 2 times square root of sine squared of theta all over the square root of 4, which is 2 times the sine of theta all over 2, which of course equals the sine of theta, which is what we wanted. All right. So there you have it. That's how we do that one using those half angle identities there. All right. That was a quick one. That was unit, what unit was that one? It's unit 6. So hey, we only have one more unit and we'll be done with this review video series. So we'll see you guys in the next one.